In your Meteor applications, you've probably seen this error before and wondered what it is that was happening. And the solution to this error, of course, is to wrap your code inside of a new fiber. But after watching this, you should have some more intuition about why this is the case. So we're going to talk about something called dynamic scoping in this video. So dynamic scoping is a way of passing variables or making variables in scope dynamically. And we'll look at Meteor's implementation of this. It's called Meteor Dynamics. And the primary class or data structure used to implement this is called the Meteor environment variable. So to start us off, let's go over to some code and take a look at what dynamic scoping actually means. All right, we're over in a Meteor application, and this is a server-side application JavaScript file, and I fired up the server in debug mode so we can play around in the debug tools here. What I want to be able to do is to call a function like one and have a variable accessible inside of the function. And one way to do that, obviously, is to pass in a parameter. So I've passed in a name here, and that name should be available inside of the function. So this is a locally scoped variable, local to the inside of the body of this function. So it's not available anywhere outside of this function, and we can verify that by going over to the debugger and seeing. So inside of here, if we're to pull up the console, we can type name, and of course we have the name variable defined there. And if we call into the next function and we drill in, at this point we pass another name, and so the name is changed to Anne. And the call stack here, you can see, shows us that we started at 1 and then we went to 2, and as we unwind and come back to 1, the name variable is back to Chris because we're back in this function 1. So this is an example of passing variables just by using parameters. But what if we don't want to modify the signature of the function and we still want to have a variable accessible inside of the function? One of the things we could do is to set a global variable. So if I clear this up a bit, instead of passing a name like this, I could just have a variable up here called name, and we'll just set it to Chris. And then instead of calling to like this, we'll just call it like this. Now the problem here is that the name variable is set up here as Chris, and it never gets set to anything else. And so it's this value for the rest of the time that it exists. So inside of function 1, if I want to call function 2 and give it a different value, what I would have to do is to save it and then assign it to something new. And then when 2 returns, assign it back to the saved name, which is sort of cumbersome. But it would achieve what we had before without having to pass in a parameter like so. So if I refresh the debugger, here we are back in function 1, and the name value is Chris. And then when we get into function 2, it changes to the new value, and when it returns, we're back to the saved value of Chris. So what we're seeing here is that at this point in the call stack, so right when we call the function 1, the value of the name variable is Chris. And then once we call function 2, and so at that point we're in this part of the call stack, the value of name has been temporarily changed to this value Anne. And then when this returns, the old value of name gets restored. And so this is sort of a poor implementation or example of dynamic scoping, where the variable changes to for future calls in the call stack and then gets returned to a previous value once we get back to the point in the call stack where we started. So Meteor gives us a much better way to do that using something called an environment variable. Not an environment variable like in a regular shell file, but it's an environment variable for dynamic scoping. So let's create a dynamic variable inside of our code. So instead of creating a global variable like this, I'll keep it global, but instead I'm going to say this is equal to a new Meteor environment variable. Now an environment variable has a couple of things we can do. We can call the get function, which gets the value of the variable, and we can call the with value function, which allows us to set the value at a given point in the call stack. So I'll start off by setting it to a value of Chris, and then we'll call the function 1. And then inside of 1, we'll drop into the debugger. But before we call function 2, I'm going to change the value to a different value, and then we'll call function 2. And let's save this, and that will drop us back in the debugger when I refresh the node inspector. Okay, now at this point in the call stack, you can see over here in the call stack we're in function 1, and I'm going to pull up the console here, and we can type name.get. And we're able to get the value at this point in the call stack by just using the get method like this. Now if I press play again, we're going to end up in function 2. So we started off in function 1, and we ended up in function 2. And notice that we also called this with_value function, and so that's on the stack as well. And what this with_value function has done is temporarily changed the value of the name variable to Ann from this point forward in the call stack. And when we get back to this point, it'll be returned back to its previous value. So let's make sure that that is true. We'll come back here to the console, and I'll type name.get again. And now you can see the value has been changed to Ann as we expect. And if we press play, and get back to function 1, and let me clear up the screen so we can see it a little bit more clearly. The value has now been returned back to the previous value, or the value that it was at when this function was called. So this is an example of dynamic scoping using Meteor environment variables. Now, so far we have a global variable, and we've been using different values of the variable at different points in the call stack. So we've been using this dynamic variable. But what about if we introduce fibers? And if a fiber yields, we shift all of a sudden to a different fiber. So now we need this implementation not just to work with one call stack, but with multiple call stacks. So let's make this example a little bit more complicated by going back to our example of handling a request using fibers. I've replaced the code with what we had previously in the video when we talked about fibers. And so let me walk through it quickly. We've created 2 fibers down here, and in each one we're going to call the handle request function, passing in the number of the request so that we can print it out to the console. So we'll start off by handling each request, and they'll get handled almost right away. And then about 2 seconds later, each one will print out their async result. And that's because it's calling this doSyncIO function, which is wrapping this async IO function and making it synchronous using fibers. And so what we want to do here is to be able to access, not have to pass in this number here, and instead just use a dynamic variable. And so instead of using a number, we'll just use a name like we were using before, and we'll use the Meteor environment variable that we defined as name. And what I want to show you here is that Meteor environment variables work hand in hand with fibers. And so just because a fiber yields and we go to a different fiber, the environment variable values are stored and resumed properly. So let's take a look. And what we'll do is get rid of passing in this number. And instead, we'll call the name with value function. And the first request will come from Chris, and we'll call the handle request function. And the second one will come from Ann. So we'll set the dynamic variable value to Ann, and then call the handle request function. Now, instead of doing printing out the number, we'll print out the name. So like so. Now inside of our handle request function, it prints out that Chris is, we're handling the request for Chris. And then the doSyncIO function is called, which yields to the next fiber. So this actually gets called before this function completely returns, but the value gets correctly updated to Ann. And then 2 seconds later, in our asynchronous result, the values are still correct, and so we get the async result for Chris and the async result for Anne. So Meteor environment variables work with fibers or with multiple call stacks, one call stack per fiber. And the reason for that is that Meteor is attaching these dynamic variables to the fiber object itself. And to get a better sense of that, inside of handle request, let's grab the current fiber by saying fiber.current, and then we'll just put a debugger statement here, which should drop us into the debugger on the right. So when I refresh this, there we are in the debugger. And let's take a look at the value here of the fiber. And if we expand it, you'll notice that it has a property on it called Meteor Dynamics. And if we expand that, you'll see the value that we've stored away here as Chris. Now, if I press play again, which I just did, and we take a look at the fiber now we're in a different fiber because the first fiber yielded. And so now in the new fiber, if we take a look at its Meteor Dynamics, you can see the value for the name dynamic variable is now Anne. In summary, Meteor environment variables give us dynamically scoped variables, or in other words, variables that can change depending upon where you are in the call stack. And they also work perfectly well with fibers.